In 2026, when people talk about operating systems that power servers, desktops, embedded devices, cloud infrastructure, networking equipment, and even parts of the modern internet backbone, two families dominate serious technical discussions: BSD and Linux. They are often mentioned in the same breath, sometimes even confused with each other, yet they come from very different histories, follow different philosophies, and make different trade-offs. To truly understand BSD versus Linux in 2026, we need to step back and explore where each came from, how they evolved, how they are developed today, what makes them similar, what makes them fundamentally different, and why someone might choose one over the other depending on their needs. BSD, which stands for Berkeley Software Distribution, traces its roots directly to Unix. In the late 1970s and early 1980s, researchers at the University of California, Berkeley, were working with AT&T's Unix source code and began adding their own improvements, tools, and enhancements. Over time, these modifications became substantial enough that BSD developed its own identity. Eventually, legal issues with AT&T were resolved, and BSD became a freely redistributable Unix-like operating system. This heritage gives BSD a very strong sense of continuity with traditional Unix design principles: simplicity, consistency, and a tightly integrated base system. Linux, on the other hand, started in 1991 as a personal project by Linus Torvalds, who wanted to create a free Unix-like kernel for his own computer. Linux itself is just a kernel, not a complete operating system. The surrounding ecosystem of tools, libraries, compilers, shells, and utilities mostly comes from the GNU project and other open-source initiatives. When people say Linux, they usually mean a Linux distribution such as Ubuntu, Debian, Fedora, Arch Linux, openSUSE, Linux Mint, Manjaro, or Red Hat Enterprise Linux. Each distribution bundles the Linux kernel with a specific collection of software, configuration choices, and release policies, creating a complete operating system. This fundamental difference in origin shapes almost everything else. BSD projects, such as FreeBSD, OpenBSD, NetBSD, and Dragonfly BSD, are complete operating systems developed as cohesive wholes. The kernel, userland utilities, system libraries, documentation, and build system are all developed within the same project. In contrast, Linux distributions assemble components from many independent upstream projects: the Linux kernel, GNU core utilities, systemed or alternative init systems, desktop environments like GNOME or KDE, and thousands of third-party packages. By 2026, both ecosystems are mature, stable, and capable, but their design philosophies still diverge in meaningful ways. BSD tends to prioritize coherence, conservative engineering, and long-term stability. Linux distributions often emphasize rapid innovation, broad hardware support, and flexibility. One of the first practical differences users notice is licensing. BSD operating systems use permissive licenses, typically the BSD license or similar. These licenses allow anyone to use, modify, and redistribute the code, even in proprietary products, with minimal obligations. Companies can take BSD code, integrate it into closed-source systems, and never release their changes. This has led to BSD code being embedded quietly inside many commercial products, including parts of Mac OS, iOS, networking appliances, storage systems, and embedded firmware. Linux, by contrast, uses the new General Public License, version 2 for the kernel. The GPL is a copyleft license, meaning that if you distribute a modified version of the kernel, you must make the source code of those modifications available under the same license. This encourages sharing improvements back to the community, but it also imposes obligations that some companies consider restrictive. Neither licensing model is objectively better. They simply serve different goals. BSD's permissive licensing attracts companies that want maximum freedom to build proprietary systems. Linux's copyleft licensing encourages collaborative development and ensures that improvements remain open. Another major difference is how the systems are developed and governed. Each BSD project has a relatively small, tightly knit core team of developers who oversee the entire operating system. Decisions are often made through consensus and careful review. This leads to a sense of architectural consistency. For example, FreeBSD aims to be a high-performance, general-purpose operating system. OpenBSD focuses on security and correctness. NetBSD emphasizes portability across many hardware architectures. And Dragonfly BSD explores novel approaches to multiprocessing and file system design. Linux kernel development is much larger in scale. Thousands of developers from around the world contribute, including many paid by large corporations like Intel, AMD, Google, Red Hat, IBM, and others. Linus Torvalds still acts as the final arbiter for what goes into the kernel, but the development process is highly distributed. On top of that, each Linux distribution has its own maintainers, policies, and goals. Ubuntu focuses on user-friendliness and predictable releases. Debian prioritizes stability and strict free software guidelines. Fedora acts as a testing ground for new technologies. Arch Linux emphasizes simplicity and rolling releases. And Red Hat Enterprise Linux targets enterprise stability and long-term support. This layered development model gives Linux incredible momentum and breadth, but it can also lead to fragmentation. Two Linux systems may behave quite differently depending on their init system, package manager, configuration layout, and release model. BSD systems, while not identical to each other, tend to feel more uniform. In daily use, BSD and Linux share many surface similarities. Both provide POSIX-compatible environments, support the same shells like bash, zsh, and fish, use similar command line tools, and can run many of the same open-source applications. If you are comfortable in a terminal on Ubuntu or Fedora, you will feel at home on FreeBSD or OpenBSD after a short adjustment period. However, under the hood, there are important differences. BSD systems traditionally use a monolithic base system, meaning core utilities such as ls, cp, ps, and grep are developed and versioned together with the kernel. This ensures that userland tools are always in sync with kernel behavior. Linux distributions pull these tools from inu or other projects, which are developed independently of the kernel. This modularity allows faster updates and more choice, but sometimes leads to subtle inconsistencies. Package management is another area where the two worlds diverge. On Linux, each distribution has its own package manager. apt on Ubuntu and Debian, DNF on Fedora, Pacman on Arch Linux, Zypper on openSUSE, and so on. BSD systems also have package managers, such as PKG on FreeBSD and OpenBSD, but they coexist with the ports system, which allows users to compile software from source using standardized build recipes. Ports systems give fine-grained control over build options and dependencies, appealing to users who want highly customized systems. Performance is a frequent topic in BSD versus Linux discussions. Historically, BSD has had a reputation for excellent network performance and predictable behavior under heavy load. FreeBSD, in particular, is widely used in high-performance networking and storage environments. Linux, meanwhile, has invested heavily in scalability, especially for large multi-core systems and cloud workloads. By 2026, both have reached impressive levels of performance, and in many real-world scenarios, differences are more dependent on tuning and configuration than on inherent design. File system support illustrates some philosophical contrasts. FreeBSD includes ZFS as a first-class citizen, deeply integrated into the base system. ZFS provides advanced features like snapshots, checksumming, self-healing, and pooling, making it popular for servers and storage appliances. Linux also supports ZFS through external modules, but licensing incompatibilities prevent it from being included directly in the kernel. Instead, Linux has developed file systems like BTRFs, which aim to provide similar features, and continues to use X4 and XFS widely. In practice, both ecosystems offer powerful storage options, but FreeBSD's native ZFS integration is often cited as a standout advantage. Security is another major point of comparison. OpenBSD has built its reputation on security-first design. Its developers audit code extensively, enable security features by default, and take a conservative approach to adding new functionality. As a result, OpenBSD is often used in firewalls, routers, and security-sensitive environments. FreeBSD and NetBSD also take security seriously, offering features like jails, secure levels, and robust permission models. Linux security is more decentralized. The kernel includes many advanced security mechanisms such as EasyLinux, AppArmor, Secump, and namespace. Different distributions enable and configure these features differently. Ubuntu commonly uses AppArmor, Fedora and Red Hat Enterprise Linux use ISA Linux, and Arch Linux leaves most security configuration to the user. This flexibility allows tailored security models but also requires more knowledge to configure optimally. Hardware support is an area where Linux generally has an advantage. Thanks to its massive developer base and corporate backing, Linux tends to support new hardware sooner and more comprehensively. Graphics cards, Wi-Fi adapters, laptops, and cutting-edge peripherals are more likely to work out of the box on Ubuntu, Fedora, or Manjaro than on most BSD systems. BSD hardware support is solid for servers and many desktop components, but niche or very new devices may lag behind. Desktop experience is another domain where Linux dominates in 2026. Linux distributions offer a wide range of polished desktop environments and user-friendly installers. Ubuntu, Linux Mint, Fedora Workstation, and openSUSE provide smooth graphical experiences suitable for everyday users. BSD can run the same desktop environments, such as GNOME, KDE Plasma, and XFCE, but desktop usability is not the primary focus of most BSD projects. Setting up a BSD desktop often requires more manual configuration and a deeper understanding of the system. This leads to a broader cultural difference. Linux has cultivated a large community of desktop users, hobbyists, gamers, and newcomers. BSD communities tend to be smaller, more specialized, and often oriented towards servers, networking, and infrastructure. This is not a strict rule, but it influences documentation, tutorials, and community support. In server environments, both BSD and Linux are widely used. Linux dominates cloud platforms, container orchestration, and large-scale distributed systems. Technologies like Docker and Kubernetes are deeply tied to Linux kernel features such as groups and namespace. Most major cloud providers build their infrastructure around Linux. BSD, however, maintains a strong presence in networking appliances, storage systems, and certain hosting environments. Many firewalls, load balancers, and routers are based on FreeBSD or OpenBSD. Companies value BSD's stability, clear licensing, and integrated design. Containers and virtualization highlight another difference. Linux has become the de facto standard for containers with a vast ecosystem of tools and platforms. BSD has jails, which are conceptually similar to containers and have existed for decades, but the surrounding ecosystem is smaller. Virtualization technologies like Bive on FreeBSD and KVM on Linux both provide robust virtual machine support, but Linux again has broader tooling and industry adoption. From a learning perspective, BSD can be an excellent way to understand traditional Unix concepts in a clean, cohesive environment. Many educators and experienced administrators appreciate the clarity of BSD documentation, especially the FreeBSD handbook and OpenBSD's manuals. Linux documentation is abundant but fragmented across distributions and projects. In 2026, choosing between BSD and Linux is less about which is objectively better and more about which aligns with your goals. If you want a system with wide hardware support, a huge software ecosystem, strong desktop options, and deep integration with modern cloud and container technologies, Linux distributions like Ubuntu, Fedora, Debian, Arch Linux, and openSUSE are natural choices. If you value a tightly integrated operating system, permissive licensing, strong networking and storage capabilities, and a conservative, security-focused approach, BSD projects like FreeBSD and OpenBSD are compelling. It is also worth noting that many people use both. A developer might run Fedora or Ubuntu on their laptop, deploy services on Debian or Red Hat Enterprise Linux in the cloud, and rely on FreeBSD-based appliances for storage or networking. The ecosystems are not mutually exclusive. Looking forward from 2026, both BSD and Linux continue to evolve. Linux is pushing deeper into areas like real-time computing, embedded systems, and advanced power management while maintaining its dominance in cloud and containers. BSD projects continue to refine performance, security, and reliability, staying true to their Unix heritage. At their core, both represent the success of open-source development in different forms. Linux showcases the power of massive collaborative, distributed development under copyleft licensing. BSD demonstrates the value of small, focused teams building coherent systems under permissive licensing. Understanding BSD versus Linux is ultimately about understanding two philosophies of how to build and share software. Neither is obsolete, neither is dying, and neither is universally superior. In 2026, they coexist, complement each other, and together form a critical foundation of modern computing.